Hello, everyone, and welcome to the Future Space. I'm your host, Daniel Fox. Our guest today is Josefine Lissner. Josephine is an aerospace engineer and pioneer in the field of computational engineering. She got industry-wide recognition for showcasing the first fully algorithmically engineered Aero-spike engine. Her company, Leap 71, based in Dubai, aims to lift engineering onto a software paradigm. Previously, she worked in motorsports with both the Porsche Formula E Team and the Mercedes-AMG Petronas Formula One Team. A few years ago, she participated in a one-day astronaut training at the European Space Agency Astronaut Center in Germany, performing underwater space walks. Josephine, welcome to the Future Space.
Hello, thanks for having me, Daniel.
Ever since I've seen your algorithmically engineered aerospike engine going around the internet, I've been looking forward for this conversation. So I'm really happy to have you right now. But before we get into that marvel of engineering, could you share with us three words that, for you, capture the essence of space?
I tried to, you told me you would ask me that. So I tried to come up with an answer that would satisfy you. I'm not sure whether I succeeded. But the three words are challenging the mind. So three words. And I can offer you three explanations for it. So first of all, the concept of space is a cognitive challenge. So think of humans who are used to meters and kilograms, and then there's something that works on billions of light years and billions of years. Just the sheer dimension of it is kind of challenging the mind, right? The second one is a mental challenge. So when you think of all the astronauts who stay in space, they need to adapt to different behaviors. They need to change their how they do things and so on. So it's a mental challenge also to be away and explore new things. And the thing that excites me most, it's a technological challenge because you need to figure out new ways how you get to planets, how you fly, how you sustain life in a different environment, and so on.
Do you think that it's part of the actual success of our species is that we have a fairly good track record of facing those challenges and going beyond? I mean, if we look at where we started and where we are now, and what nature has given us and where we're taking it, do you think it's actually it's one of our core foundational structure of facing those challenges and actually succeeding and going beyond?
Absolutely. I mean, this is how humans have always survived. They are not the strongest in nature. They're not the fastest. Maybe, well, yeah, they are the smartest. So the way of how they survived in the past is figuring out how to solve challenges smartly. I think it was Steve Jobs who said that the computer is like a bicycle for the mind. So we cannot run fast, but we can make tools that make us quicker and that make us stronger and so on. And this is why I'm so positive about technology. It's the essence of what humans do. They invent new things to tackle challenges, and they love that, and that's their means of survival.
I always feel like we don't give ourselves enough credit. We think that technology evolves and we're like powerless towards it, just like, oh my God, AI is going to come and then it's going to take over the world. And yes, I mean, the tool will, but also our capacity to face it and to manage it. And also the cycle of, oh, like even social media, I see how the younger generation has a different relationship with social media now because they've grown into it. They see the gains and the losses, and now they change their behavior to it. And our relationship with technology is always this dynamic, relationship. It's not a static where, we can't do anything. So even as technology gets better and more ingrained into our lives, we are developing the mechanism to make sure that we keep our humanity. I mean, do you believe that we have the capacity to nurture and to defend our humanity as technology becomes even more increasing into our lives?
Um, I struggle with the thought of us against the technology, right? As I said, I think every technology is man-made, and technology only has a purpose through the humans who use it or who invent it. And I mean, me as a technologically positive person who wants to invent stuff, it kind of worries me that the general public or let's say the younger generation is kind of not necessarily negative against technology, but they kind of take it for granted. So, as you said, they're kind of paralyzed and they don't actively think about the fact that every technology is driven by humans behind it. It not just magically happens somehow and then we just deal with it. It's at the core driven by humans. And I think this is one of the key factors to keep in mind when you think about solving climate change. It will not automatically happen. It needs to be driven by some humans who actually push for it and who have the intent to solve it, right? And then they will come up with the technology as the consequence of their intent. So, but yeah, it does worry me because there are movements that say technology is generally to be seen critical and technologists are seen as, I don't know, I don't know how to say it, but the younger generation needs to get back to this mood that we had during the space race in the 60s, right? So they realized, oh, there's a big challenge. Humanity, or the US at least, committed to it. And as a consequence of it, many young engineers wanted to become, or many young people wanted to become engineers and take part in it. And I think a similar kind of movement needs to happen today.
Before we get into your work in Leap 71 and Dubai, I want to just touch one more thing about our philosophy that we started to talk about right now. Yes, there's the science and the technology story of going to space and here on Earth, but what do you think is the human story of going to space?
Well, I do think that ultimately the human story of going to space will be saving Earth for the reasons that I just said. So, not necessarily saying that this is the intention or the motivation behind it. Maybe it's just exploring things. But as a consequence, and this will be the main result, we will develop technologies and the mindset to solve climate change. Because in space, if you want to maintain life, you have to come up with closed systems, sustainable energy generation, all of these things you need on Earth. And by the way, I'm now based in Dubai, right? When I look at the city, it's basically an experiment, which is similar to maintaining life on Mars, because Dubai is built in the middle of the desert. There is no rational reason for humans to live here. Yet it's a thriving city because they have managed to put technology in place to maintain life in this region here, which is quite exciting if you look at it from that perspective. And there are other perspectives too, obviously. But this is my perspective on Dubai. It's kind of an experiment, practicing for Mars, living in the desert.
And leaving the nest has always been at the benefit of what we leave behind. It's always part of the solution. And these boundaries that we keep pushing and exploring actually become, the part of the human experience. Like we started in one little village somewhere, and then we went beyond the mountain, and then we got to the ocean, to the beach, and then we looked over, and then we figured out, how can I go over there? And then we find a way to float and then to navigate with the wind, and then we go beyond, the ocean. So we're taking life to these new places, always elevating the human experience. And now, space was just, I think, the realm of science fiction until it wasn't, and until we realized, oh my God, this is just, this is what we've been doing and we keep doing. Now, you came to worldwide recognition when you published the results of your amazing piece of, I want to call it art. When I saw it, it was like, I wanted to photograph it, just the shape of it. Tell us how did it come to be, and what was your journey into developing this engineering / art / future?
First, I really got annoyed that people would call it a piece of art. So that happened quite frequently. And I'm like, this is not fair. I put so much like calculations and brain into this, and then people call it a piece of art. But we can talk about later. I kind of changed my mind a little bit on that. But regarding the background. So I'm an aerospace engineer. I studied in Germany, very traditional engineering education. And what I realized at the end of my studies is that I had not learned how to computer code, how to program. And I figured, okay, if I want to be a 21st century engineer, it's probably a useful skill to have. Yet no one at university really taught me how to do it. It's kind of strange. So I started teaching myself. And as I was doing this, I go through these phases of very strong interest. So I used to be super interested in motorsports. And then at this phase, I was super interested in finding out how rocket technology works. So I would watch every video of everyday astronaut, everything that I could find on YouTube to teach myself how they work. And at that time, I would watch one of Everyday Astronaut's videos about Aero-spike rocket engines. So I understood that they are one of the fundamental challenges that have not been solved. It's a rocket nozzle that is inherently more performant, more efficient. Yet it's super hard to cool and very difficult to build because they're very compact. So they used to overheat. They used to be quite large when you execute it with traditional means. And so in the 60s and 70s, there have been prototypes and tests of these Aero-spike rocket engines by companies like NASA and Rocketdyne, but they never left the test stand. So back in my mind, I knew, okay, this is some kind of challenge that's been hanging around. And then while I was researching for technology and learn about rockets, Google News would actually come up with an image of a company called Hyperganic, which was back then a tiny startup in Munich. And it showed this object, which was also like a bell nozzle, a rocket component. And it looked so different to what I had seen in my studies and my research. So it intrigued me. And I actually applied there for a job for my master thesis. And then I learned that they would use a new method of how they generate objects. They use computer code to describe how an object works, and then it's automatically generated. And so all of these threads kind of came together. I wanted to learn how to code. And I knew that there was a challenge that I could tackle, the Aero-spike engine. And there was this company saying that here's a new way of how to do things, but very at the early beginning. When I joined, I was kind of the first engineer. So I said, okay, I try this new method and try to create a Aero-spike rocket engine using that. And this was the motivation, and so it came about. And, oh, actually, sorry, I have a tiny one. I show you. This is the result of it. One of the results.
It's so if I understand correctly, the 3D printing actually printed it in an open version, right? You didn't print it and then cut it through. The printing capacity allows you to do exactly what you showed us.
Yeah, it was printed like that because I designed it to be cut open so you can view it. It's probably going too much into detail right now, but it's quite funny because when you 3D print something, you have certain constraints, right? So if your overhang angle is too flat, it will not print because there's no material underneath, so it doesn't work. So you have to comply with constraints. And first I would generate the entire rocket engine, so the full one, and then cut it. But by cutting it, you would actually have like little pieces that have no support underneath anymore. So if you print the whole thing, you could print it. If you cut it, it's not printable anymore. So then, which is kind of the other way around, I designed the cut first, and then around this cut, I designed the Aero-spike, so that I knew that in the end, the cut Aero-spike would be printable. So that's the story. It's the story of that showcase. that placing the cut gave me more pain than designing the rest of it.
It's so the engine is not just a proof of concept. It's actually you've tested it and it works, or right now it's just the concept is forward, and now the next phase is proving that there's actually an application or it works, the way that you want it. Where are you in that timeline?
So my geometry is basically a showcase. It's showing the world that such an object can be generated through the method. So see it as the first validation of the method itself. The part itself is not tested yet, but I'm working on that because I believe that if you have an algorithm that can automatically generate rocket engines and that is somehow validated that the rocket engine will work, I mean, this is a long stretch, right? But assume you have an algorithm that can do that. I believe that this would be a tipping point in the entire propulsion industry because when you think of startups, they they put a lot of effort into making something work to start with, right? So this is like the biggest amount of work to get something to a level that it works. And for that reason, many startups actually stick with very old designs. Most of the designs you see nowadays, they are just adaptations of whatever has been around in the 60s, 70s, and slightly adjusted to be 3D printed, for example. But this is kind of as far as it gets so far, which is super boring. But no one gets further because the initial step is so hard. And if you had an algorithm and you open source it or you sell it and it gives you a working engine to start with, then, I mean, you would eradicate the entire first section of the build-up phase for such startups. I mean, that would be super interesting.
It's, I mean, just the opportunities and a future where the AI is helping us figuring out these new product, whether it's new medicine or, I mean, you know, you were talking about the engine, and then in my mind, I was even thinking that AI could help figuring out a new, fuel, a new molecule that help, like each fuel is specifically built for a type of engine but like the world, I mean, it's the possibilities are just endless once you get that foundation with the AI, and then let the AI kind of run, giving you all these the computational power that before was not possible, right?
Yeah, you're absolutely right. I mean, if I'm allowed to rave about engineering and the current state of it, it's super manual work. Don't be mistaken. Engineers spend most of their time sitting in front of CAD programs, which is basically like a 3D drawing tool, and they draw things from scratch. So they take a sphere and then they take a box and then they subtract the box from the sphere and then they put a hole in it and then they draw a line and then they project it onto the sphere. And all of these things they do over and over again. And these CAD kernels are designed for manual work, and it's manual labor in the end. And it's really hard to automate them because the way they have been created on the software basis doesn't really allow for automation because it's assumed that someone operates it manually. And it's kind of ridiculous. I did that when I worked in Formula One. I would draw little winglets on the race car all day long, again and again and again. Similar winglets, every time slightly different. You do it all day long. And I mean, in Formula One, it's exciting, but think of an engineer who has to draw the same bracket for like 5 years in a row. It's not fun, and it's a waste of brain power, frankly, because think of what an engineer does, right? He has an algorithm in his head. So he's like, okay, step one, I need to do this. Step two, I need to do this. And then he manually executes the algorithm by clicking buttons. It's, when you think of it like this, it's quite ridiculous. And all that I did was basically try to encode those steps that I would otherwise manually do. I would write computer code, and then it can be executed by the computer. So you're like a factor of 100 or 1,000 or whatever, you're quicker. And you can change the input parameters and then generate a new variant, and it will be, again, a factor of 1,000 quicker. So this kind of algorithmic method that opens up for very quick iterations, which makes the whole thing more playful. Because if you need 3 weeks to design that bracket, well, you don't really experiment and go off track because it's so time intensive. But if it doesn't take time to do another experiment and another one, then you can go a little bit further, which wouldn't do otherwise. And so it's more of a playful way, and which allows for experimentation. And it moves the engineer to a more abstract level. So instead of me doing manual drawing, I put in my thoughts and try to teach the program of what steps to follow. And when I look at the results of the algorithm, I can steer the algorithm if it doesn't achieve the results that I want. I can go back to the rules and adjust them slightly. So I'm more like the captain of the ship rather than the guy who has to do the ruddering.
Yeah, you're like the chef, the chef, the leader of the orchestra, kind of leading all these
Yes.
instruments. The
Yes, that's right.
there's a physicality to experimentation that will never be replaced. There's as much as we can predict, we can work with AI. There's a value. There's a extreme big value of the actual physical experimentation, but our capacity now to gather information without going through the tedious work and one of the thoughts that is always in the back of my mind is, I was recently up in the Arctic or down south in Antarctica, and and here I am in those places where before, if you and the stories of expeditions of people who would go and suffer just to get the weather information. There's this, famous expedition of this guy who went to spend the winter in Antarctica and almost died so many times, and he's constantly saying, "Oh, I need to write down the weather," and the human cost for the seek of knowledge, for the gathering of information. Now we have we have a drone on Mars, we have rovers on Mars, we have satellites that give us the capacity to gather information without putting us at risk. And now we have AI who's going to be giving us the capacity to process all these different options and to go beyond, and just giving the kind of the directives and let it run so that we can take the information and do the abstract. This is what we've been doing for, this is what I think the science and then the engineering has been given us, is the capacity to actually go beyond the information and the technology and just always actually be ahead of it. We're not behind of it, we're ahead of it, we're taking it to new places, right?
Partly I agree in terms of looking at the past. I think I agree, especially in engineering, there is this trend of simulating everything before you ever produce anything. And I think that has been valid until we met 3D printing and exploited the design freedom that gives us. Because now we are challenging the simulation methods. So if I show you this again for a second, there's no way you can simulate that with existing simulation methods. And I tried. I tried hard. And so I think if you think back again to the space race here in the 60s, they had no data for simulation. They didn't have computers. They didn't have any simulation. So they figured out everything through physical testing. And by doing so, they built up this huge data set of how something flies, how something behaves, how something burns. And from those experimentally gained data, they then built in the following decades, they built simulation models based on that data. So even if you look at CFD, so fluid simulations, they heavily rely on turbulence models that some guy in his lab tested with, I don't know, a stick and a flow and so on, and then he observed and measured. So not everything is pure mathematics. Most of these things are actually heuristics, so something that someone tested. And I think we are going back to a certain extent to this area where we have technology that we cannot predict yet because it's a step ahead again. So we are at this right now. The Aero-spike engine can hardly be simulated, but we can generate loads of them. We can test loads of them. So if we do that in the next decade, we will develop our simulation models such that we then catch up again. But it's quite funny. It's always this kind of race between prediction, simulation, design, manufacturing. So with computational engineering, you also challenge what the 3D printers can do. So it's always this race of who catches up and who pushes ahead. And this is kind of then the entirety of technological progress.
Now, you recently, I mean, officially, you've been working on this for quite some time, but recently you just started your company, Leap 71. Can you take us through the idea behind the name, the Leap, the 71? What was the creative process behind it?
Okay, I start with explaining what hypergenic was, where I used to work for 2 years, and then I can derive what Leap 71 does. So Hypergenic's goal was to move engineering to that software paradigm, as I explained, and it's a platform company. So it developed a geometry kernel that allows for automation. I explained previously that existing CAD kernels are a pain. They will fail if you try to push it hard. So the first invention that needed to be made is basically a geometry representation that doesn't break, that you can automate reliably. And Hypergenic came up with this voxel engine. So this object that you see here is basically in computer code represented as little bricks like Minecraft. This is kind of the underlying geometry model. And it's a platform, so it's open to engineers to learn how to code on it. And I was leading the strategic engineering group, so I was tasked with pushing the technology and showcasing what's possible. And then we also had a solutions arm in the company, and marketing, and so on. So it was almost getting too much for one company to do all of this, from building the foundational technology to applying it to showcasing it to and so on. So I basically decided to do a startup and put it on top of the hypergenic technology, and then do all of these engineering projects using that technology without being inside the company. It's kind of too much for one company that wants to be a platform company, but also wants to do engineering projects. So it's kind of a big stretch. And I would just want to be my own chef in that sense, because I thought I could do way more than what we've done already. So this is why I decided to start my own company. And because I recently moved to Dubai, I called it Leap 71 because the 71 is connected to Dubai. Leap obviously comes from leapfrogging, and 71 is the year when the UAE will turn 100 years old. Now that sounds very patriotic, but there is actually a very inspiring story to the UAE and Dubai, because it is exactly that story of starting from scratch. Like 50 years ago, there was nothing here, just desert, to building this absolutely insane city that probably comes closest to a future city in the present. And I'm just super inspired by seeing what's happening around me, by looking at the highest building of the world, just like every day. It's casual, it's usual what you see. And it's just, they need to get credit for what they have built here. It's quite remarkable, and I found it very inspiring. So this is why I chose this place as well. So I don't know how people will look at that kind of aspect, but because that recently happened, I kind of chose the number to go with the leap.
I think anything that resonates with you and you're proud of the story behind it is in my book. Can't complain about that.
Okay, good.
You by the way, Dubai is the Museum of the Future, correct?
Yes. Yeah.
Did you go and see it?
I did, yeah. I actually got a tour from the director of the museum, and it's the most advanced building in the world. I don't think people might necessarily know how it looks like. It looks like a big donut, and it has amazing calligraphy on the outside. Now it's not only like panels; it's actually windows, and it has this torus shape. Which means that if you go inside and you take the elevator upwards, then you have the ceiling above you, but the ceiling kind of curves around as you go up. So the ceiling becomes the wall next to you. You keep on going up, and then suddenly the ceiling, the wall becomes the floor as you go further up. So you have this experience of everything being turned around as you travel inside upwards. And there is this story that they didn't have a fabrication method for the panels and so on, because everything was different. They would have needed like 2,000 different molds of it. So they invented an adaptive mold which can be actuated and kind of achieve every shape you wanted to. And a lot of technology went into making this building possible, which you don't learn about if you go into the museum. That's the biggest shame.
Now, if you ask me, what if there was one building in the world that would actually want to go and see, it's the Museum of the Future. There is, like, I don't get, I when I saw it, the same way that when I saw your Aero-spike engine, I don't get much excited about structures because yes, they're great, but from time to time there's something that comes up that suddenly just gets me really excited. The Museum of the Future is one of them. When I saw it, I thought it was the vision, the outside the box, the concept, the everything about it was absolutely pure. You're not gonna like this, but for me, it was a combination of art and engineering and science. And really, the culmination of everything that we can do best is when we mix all these strengths that we have, the vision, the artistry, and then the engineering, and we create these things out of the air, and then just the beauty of it. So the museum, like I would get onto a plane today, and I would drop everything just so to get a private tour.
We can arrange one if you come and visit.
We'll talk about that. Now, I want to earlier, and because I kind of talked about it a little bit again. When I said art and your work, you cringed a little bit, and now you said you're getting better to it. What was it about that statement that kind of triggered a reaction?
I mean, I think the statement, it looks like a piece of art, would demolish the kind of engineering effort that went into it. And I thought of what engineers are used to look at. So engineers are used to look at plain functioning objects that has no more detail than what is absolutely necessary, and whatever they can build with their tools. So most objects actually look quite primitive and simple. And in the software paradigm, it doesn't necessarily hold true anymore. So traditionally, you only do as much as you have to do until you reach a functional state, and then you stop, and then that's your design. But the way I work is I write software modules. So I'm basically building up a library of engineering vocabulary that I then use to describe engineering words. So the words would be a rocket engine, or I don't know, a manifold, or an electric motor. But I'm recycling these modules all the time. So I don't do, once I've done them, I never do them again. I never touch them again. So once I have a module that gives me a flange, a variable flange, I always use that module. I never do a flange from scratch again. Once I have a channel that a module that routes cooling channels, I never need to do it again. I can just recycle it and feed it with different input parameters. So this is very tedious at the beginning, but after time, you build up this library and all of your objects become more complex automatically because you always use the latest stand of what you have developed of the past. So you're building always on top of what exists. So for example, a cooling channel, okay, but now I do a cooling channel that has ribs inside. And once I've done that, there is never a reason, if it makes sense, to have a cooling channel without ribs or without a pattern on it or whatever I want, right? So it never makes sense to do anything less than what the latest best was. And so I believe that over time, objects will become more complex, and also it doesn't cost anything extra to make them look beautiful, because I can just add the algorithm that makes it look beautiful. It doesn't cost me any additional effort. So why would I not choose to make it look nice if it doesn't cost me anything? The argument in the past was, oh, if you want to make it look nice, it costs extra. Now we don't want to spend time on it. If that no longer holds true, I believe humans would be very happy to be surrounded by nice looking objects, whether it makes sense or whether it's absolutely necessary. I don't think that's the question necessary, but I think it opens up a completely new way of thinking about functionality versus shape versus aesthetics, and these will converge. And in a way, yes, I'm proud of the fact that people think the Aero-spike is a piece of art just because it's so different to a traditional rocket engine, but it didn't cost me anything extra to add all of these details. So that's kind of the perspective. And also, I talked to some artists lately, and I got some respect for them because one of them said that the artist is the ultimate technologist, which means that artists use technology in a playful manner. So give them a tool and they will completely exploit it. They will go insane. They will push the tool to its absolute limits in order to find out what is possible. Engineers don't do that. Engineers, they are given a tool and then they are given a goal and then they try to combine the two somehow. But if they don't need to exploit what the tool can actually do, they won't do it. They just do the absolute minimum of what is required in order to achieve their goal, to design whatever. So I looked at that and I'm like, okay, wow, that's actually true. Artists are usually the first who adopt a new technology and they don't build anything functional, but they completely exploit what the process can do. And to some extent, yeah, I try to do that as well. Like there is this new method of computational engineering and I just want to completely exploit it to see what we can do. And then I also do some functioning stuff, but I also just want to explore the process.
I mean, I'm thinking of artists like Refik Anadol, who's, playing with AI and creating these installations that are absolutely amazing without, seeking to do anything other than just the visual impact of it. And his work will be taken by others. But, also when you came up with the Aero-spike engine, there could have been a way to just put it plainly out there, and put it in context. Like, it could have been just a photograph of you with the engine on the desk and kind of, but you chose to present it in visually in a way that took it beyond the and a little bit.
Are you saying that as soon as I'm in the picture, it's not visually appealing anymore?
No, but I think that you understood also the power of the presentation, and if we, you spoke earlier about Steve Jobs. I think that was one of the strengths of Steve Jobs compared to, let's say Microsoft. Microsoft definitely represents more the purely engineering vision of the world around you, and Apple saw, yes, we need the engineering, but there's a human experience, there's a human relationship, there's a visual relationship with the products that surrounds us. And we have the capacity now, like you said, to merge these. So it's not one at the expense of the other, but it's a combination of being able to build, but being visually pleasant also for us, right?
Yeah, I think it must be because we're talking about a completely new way of doing things. And if you talk about the practicalities, yeah, I sit down many hours a day and I just write code. So it doesn't look sexy at all from outside. And it wouldn't be an easy sell to engineers because why would they change what they've done for the past 20 years and blah, blah, blah. And it's difficult and so on. So you need to showcase people what they can achieve if they go through learning this new process, and you really need to tackle it from that side. Because if you tell anyone, oh, you need to learn coding now because of that and that, they will object. They won't see the necessity. But when we showcased the Aero-spike in Long Beach last year, there were young engineers coming up and said, I want to sign up for this platform. I want to learn algorithmic engineering because I want to be able to build things like that. And this is really where the motivation comes from. It doesn't come from showing them the tool and saying, this is a hammer. What do you do with it? I don't know what it is, whatever. You need to showcase, this is a house I built with that hammer. Do you want to build a house like that? I mean, that's probably a very bad analogy, but
No,
so
it's a very good one.
it needs to be really motivated from the goals and from the perspective. And again, technology must have an intent. So there must be humans who have the intent to go beyond what is the state, and they need to seek new technologies that will give them superpowers. And that's essentially what this software paradigm will give you. It will accelerate your productivity. And that should be the motivation. And so to add to that, yes, Steve Jobs was probably the first one who was successful in establishing almost like a luxury brand in the technology sector. And I think that's quite interesting, because it's exactly that thinking of coming from the desire side and showing people what they want, not necessarily how they have to do it. That's the main difference between Apple and Microsoft. And we had a similar thinking about that. We want to build aesthetically pleasing objects that excite people, and so they are motivated about the topic.
I think it's also what Elon Musk has done with the space and the electric car, going beyond the function and making it, visually pleasant. It doesn't have to be, clunky and just, slave to the function of it, but there's a natural design and human relationship with it that can be applied, without sacrificing the function. Josefine, are you able to give us a timeline of where you are right now and where you're going with your company, and when do you expect to come out with maybe like a working product?
Ooh, hard to say. I mean, I'm very, very at the beginning. I incorporated my company a couple of weeks ago. So it's right now this phase where you realize that being a founder and an entrepreneur is completely different to having an employment and working for someone else. It's kind of an interesting shift in your mind, where you don't want to go back into working for other people at all anymore. So it's very early days, but there's a lot of interest to collaborate with players worldwide who do want to push this Aero-spike or any kind of propulsion system onto this algorithmic level together with me, and then also test it. How long it will take, it's really hard to say right now. I mean, maybe we will see results early next year. That would be the most positive way of thinking about it, but I really cannot tell right now. It's hard. I will say though that Leap 71 will not only do propulsion systems, so I will also engage in electric mobility. Electric motors are super interesting for 3D printing aspect, and many more. So it's not specialized to rocket engines, although I have a bias towards them.
Well, I can't wait. I mean, the world can't wait to see everything that you're going to be coming up with. We started with three words that capture the essence of space, and I always end with the following question: You've dabbled, you've worked in the motorsport industry, which is that's a total. I mean, we could have another conversation on that. Now you're aerospace. You're from Germany. Now you live in Dubai. You have a wealth of wisdom, I would say. What would be your three words of wisdom for anyone who listens out there, whether they're young or older, or just what would be your three words of wisdom?
Ooh, that's a tough one. I mean, one word is be bold, so boldness. Many engineers are kind of gray, so it's refreshing to see people being authentic in this space, and whether it's art or whether it's engineering, people who openly talk about how they create things, who do stuff. Be bold, educate yourself. I know it's not one word, but educate. I think that the education systems are so massively outdated, they don't prepare you for a useful job in industry. And I think young people need to be aware of the fact that it's their own responsibility to teach them what they think is necessary, skills-wise, knowledge-wise, And I've always done that. So I'm mainly an autodidact. Most of the things I use and work upon is whatever I taught myself and not what I learned at university. Educate, bold, multidisciplinary, I would probably also say. It's also kind of a disease in engineering and probably with young people as well, that they are being told to specialize into something and then become an expert in that or that field. I don't believe also that this holds true anymore because I see it with my work. So I try to encode engineering knowledge, and I very quickly came to the point that if I have an algorithm that routes cooling channels, I can recycle that algorithm to route a capillary system on a biological application. So you get into this territory where you find engineering principles being easily translatable between biology and, I don't know, mechanical engineering, aerospace, thermal management. So there's a lot of cross-pollination between those disciplines. And I have always benefited from having a very broad background in all of these because you can understand them. They all work on the same principles. So specializing was always something that gave me a headache. Like whenever I felt like I have specialized in that, it made me feel like 3 other doors just closed. So being a generalist, I think, is a good thing.
If we want to, bring back Steve Jobs, he said, be curious, always stay hungry for new things, and don't be settled for once you've reached anywhere. Always look for beyond, what other door to go through. Josefine, I can't, this is going to be exciting to follow Leap 71. We'll make sure that we have the link to your LinkedIn profile and then to your company. You're also on Instagram. But we'll be following your work, and we can't wait to see what you're going to be coming up with. Thank you so very much for taking the time today.
Is the time already over?
It is.
Thanks so much. Thanks so much for having me.
Yes, we could carry on. I think this is. I love. For me, one of the things that I love the most in life is actually having dinner with interesting personalities and sharing the food, feeding our stomach, but at the same time feeding the mind and sharing a good bottle of wine. I think that the essence of the human experience can be summarized in that experience. And I'm sure that you and I will have that opportunity together.
Beautiful.
Thank you.
Cool.